All right. So we may have to just sally forth with, teach to the students that you have, not to the students that you wish you had. So attendance is going to be pretty fast because there's only 2 of you. So I am starting up with trying to be a little better about attendance. Not once again because I take off points or whatever for you, but I'm definitely curious why people aren't in class. So especially since this is a higher level class. Let me see. Is there anybody who just texted me about like, hey, Dr. E, I can't be there. Nope. Nope. Just my girlfriends all sending positive vibes to each other. So, because I'm that friend, I send out the GIF that's like the teddy bear sending hugs to all my female friends. So, wrong book. Right book. What were we talking about last time we were together? Actually, even before I get started on that, did all y'all get oh, my brain just glitched. Did I review where you find recorded lectures now and that workbooks and all that kind of stuff? Did I thought I reviewed that with you on Wednesday. Did I go over that on Wednesday? Skylar, I don't think you were able to make it to class on Wednesday. Or oh, it's like an inverse. I think you sent out an email. Okay, so let me walk through that really fast because it doesn't hurt. Oh, a student from one of my very few students who didn't make it to my GEO 102 class is like, I'm sorry, Dr. Evie. Oop. Let me get off of the grade center before I switch this because other people's grades is not your business. All right. I wasn't, but I saw the email. Okay, cool. So just as a quick walkthrough, course information, I just want to walk through this really quickly. This has changed a little bit. So this one, flexibility in finding recorded lectures, I wrote updated to indicate that there's a new procedure here because I'm uploading everything to YouTube. So it was more to switch to Zoom than I knew at the time. So when I agreed to it. So this is a channel with all my classes, and these are the different playlists. You're this playlist. For some reason, the lab uploaded just fine, but apparently the lecture was on the cloud. So I have a copy of that lecture now, and I'll be uploading that. I like to also edit the videos a little bit beforehand because like there doesn't have to be the whole section about like how you doing and all that kind of stuff. Let's get rid of this. Let's look at the next thing under course information. Look at the schedule. I just wanted to remind you of this because I don't want to be that one professor that didn't remind you and then have students go like, what the hell is happening? So our schedule, this is our schedule for the class down here. This is the college academic calendar. Remember, I have that. I thought it would be useful to have on hand. So next Tuesday, it's not relevant to this class because this is a Monday, Wednesday, Friday class, but next Tuesday, there's no classes, okay? So I just wanted to remind you of that so you had that in the forefront of your mind before we proceeded any further, because I don't want you to be hella confused because you're like, where is everybody? There's no classes. Oh, also, I got an update from the AVP regarding snow days. I was told that we have no choice, and if there's a snow delay, it's a delay. And like, that's what it is. The whole like check with your professor are for people like nurses where they have to make it up. Like nursing and a lot of the courses where you have to get a certification at the end have to have a certain number of hours doing a certain number of things. So, and that's rules by the state, not by JCC. So those people need to contact their professors to see if we have class. If we have a snow day, definitely do not have class. Does anyone have any questions about any of all of that? Okay, one last thing. Excellent. Thank you, Tracy. Thank you, Skylar. One last thing about lecture notes. Reminder, I post lecture notes. I didn't post the outline for week 4 yet. Bad me. Click to submit. What was I on? Rename this. Click to view is what it should say. I need to update this. It's a little bit different for my other classes because they all have the same outline. So I make one, and sometimes I forget to update your class. No, not to submit. Why did you do that? This is what I have to click. Let me fix this really quick. I'm so sorry. I just want to make sure this is done while I'm looking at it. Otherwise. But the lecture notes, what a day, LOL. I'm sorry. Lecture note, click to view. This is where it's all stored on OneDrive. And you should be able to view the lecture notes as a PDF. Okay. So, and I do go backwards. I do scan overlapping. So I go back a little bit further than the week all the way up to what I have. And I try to post those on Fridays, just like I always, the quiz will go up later this afternoon as well. Any questions about any of that? What a day, LOL. I'm sorry. I wish everything was more organized. Okay, and that's not a student, that's an ex-husband. Let's keep moving. I don't know if you heard my phone, but my phone went off. So, so one student will be joining us. So what have we been talking about? What has been our focus? You guys weren't here on Wednesday, but maybe you looked at the notes. What have we been talking about? Me and Skylar should get extra bonus points. You know, honestly, in this sort of situation in the physical classroom, what I'd give you is not bonus points, but candy. So this is the kind of like, you did it correctly, but I don't want to inflate your grade, so have a bonus candy. So you would be having candy. So imagine yourself, you earn candy. If later you're like, I don't know if I should buy that candy bar. Dr. E says you have earned it. So, so what have we been talking about? Do either of you know? Even thinking back to Monday, because we covered it on Monday too, or Friday, sorry. Opacity, excellent, Tracy. So we've been talking about light, and we left off with opacity and transparency. So as light goes through the atmosphere, it's opaque to some things and transparent to others. And we learned that the sun is an angry bastard of like we usually, and this will come up repeatedly in this class, We've always drawn the sun as like this smiling, I love you. I have stickers with that on there. Smiling, I love you. I'm the happy little sun. Sun is an angry, violent star that's belching out the entirety of the electromagnetic spectrum. And that's what we had. We looked at it in the book together. This is mother puss bucket. That's better. Okay. So we basically, now if you have a physical copy of the book like me, this is in the front cover. Otherwise, we saw it in the electromagnetic spectrum is figure 3.8, page 67 in your Pearson text. So we talked about this diagram right here, the electromagnetic spectrum, and longer wavelengths and shorter wavelengths. And we noted that the atmosphere lets through some things and blocks out others. And what was one of we called this life's friend in astronomy's and the atmosphere, life's friend in astronomy's enemy. Why is the atmosphere life's friend and astronomy's enemy? It's for exactly the same reasons. Why is that? Why is that? That may be an essay question. We can't see as much as we want. Excellent. So the take-home message, I'm going to go 02, 19, 2021. We can't see as much as we want in space. So take home of we can't see all the spectrum that stars, including the sun, stars including the sun produce due to the fact that the atmosphere, why did I close this? I didn't want to close this. This is keeping me organized as I teach a new class, is actually literally using the book's outline. What topic does the book cover next? Then Dr. E will cover that next. Will produce due to the fact that the atmosphere is opaque to certain wavelengths. Why does that, so that explains why it's astronomy's enemy. Why is it life's friend? Protects us from what? What parts of the spectrum are dangerous to life? UV rays, what else? Excellent, Skylar, excellent, Tracy, what else? What other radiation produced by the sun is dangerous to us? Gamma, excellent, Tracy, what else? Not just gamma, let me put that curve. It's on page 67 of your book. Let me put this curve. X-ray, excellent, excellent. So on the other hand, the atmosphere protects us from shortwave, high frequency, ionizing radiation, which includes UV, X-rays, and gamma rays, which can mess with DNA and are therefore dangerous to living things. Hey, Rod, I'm so sorry I fell asleep after my first class. Hey, Rodney. Hey, Christy. No worries, no worries. We're just getting started. I reviewed a lot of the stuff I put in that email, and it'll be in the video, and you're not required to show up. I just wanted to check if you wanted to be here. Just a reminder, we do have class. And trust me, I totally would like, I would be napping there with you, man. Ah, damn it. I hope college lets my pencil bag up in, well, I accidentally up in. Oh no, there's highlighters literally everywhere. Okay. So this is an important take-home message from this discussion that we ended with last time. Okay, so we can't see the entire spectrum. This I may ask you to paraphrase in some kind of essay. We can't see the entire spectrum, and that means that we can't see the whole spectrum of stars. And as we're going to learn when we talk about both black body radiation, the topic next, and spectroscopy, which is the next chapter, those both yield light color, yields a lot of information for scientists, a lot of important data for astronomers to understand what's going on with the star, understand Doppler, understand the composition of stars. At least it's Friday, right? All of that important information. But if we didn't have, so the atmosphere is the enemy of astronomy. However, if we didn't have that atmosphere, we would have no life. So I'm going to put that in our neon orange box. Neon orange, neon pink means this is important. This is a take home of a larger discussion. So definitely have this in mind. So should I keep moving, or do you need a moment to write this down? Are you ready to keep moving? Because we're next going to talk about thermal radiation. You are going to look.
Question before we move on.
Awesome, Tracy. Shoot.
I know I asked this before, but like from the quiz, I really had no idea how to do the math for the essay question. I just feel like I didn't have enough information to do the entire equation. You know what I mean?
Oh, you both don't feel okay. So then let's, how about I make that part of after I grade it, because grading it will let me know what everybody else didn't understand too. And I'm going to grade it. I wanted to get to grading quizzes regularly on Thursdays and Fridays, and it looks like Saturdays are actually quiz grading days. So, hey, Ty, good to, well, he's connecting. So let me go ahead and I wish I could put a sticky literally on, I'll put a sticky on my computer. How about that? Put a sticky, or you can just remind me, I trust you, you're adults. So once I've graded everything and I see where everyone's mistakes are in the quiz, because I don't want to go over it like 12 times, I will go over how to solve that problem. Does that sound like a good idea? Yeah. Ty, your microphone's on. I'm gonna mute you. So, so thank you, Rodney. Thank you, Tracy. Yeah, I'll go over that and we'll solve the problem all together. So, and that'll help you with future equations as well. But yeah, you should have enough information to answer the question. Oh, there's sticky notes. I'll even put it on a sticky note, GEO 141, and I'll put review quiz 3. And there were a lot of more complicated questions in quiz 3. So I'm just going to go ahead and I'm going to actually stick that in our notebook right here, hanging out, so I will not forget it. So good question. Other questions before we keep moving on to Planck black body radiation? Because once again, once I see the quizzes, I will have a better idea of what everyone was having trouble with and what specific problem you were having with that question. Okay, let's keep moving. Some of it might be that we need to slow down and do a math review. We may need to because this is the advantage of having a roommate that 2019, 2021 continued.
To be honest with you, I skip a lot of the math homework or math problems in the homework too. Some of them I literally don't even know.
Okay, so that's.
I'm just totally being honest.
No, that Rodney, that level of honesty tells me something. So if we need to go backward, if like we need to stop, pause, take a week to really review math.
You're not going too fast. Like, I'm understanding a lot of the information that you're teaching us, but we haven't like dove in deep to like the math portion itself. So like it's only ever a few questions on the homework assignment, so I just reveal the answers most of the time.
Okay. Okay, so that's good to know. And I might incorporate it, knowing that I might incorporate it into a lab where we spend like an hour and a half just reviewing a couple of the basic math concepts that you might need. Because I will tell you, this is the advantage of actually having friends who are going to school at JCC. My roommate took Math 125, and a question that we always had in science was, why can someone take Math 125 and not be prepared for the math that we do in science class? And then I looked at the math that she was actually doing in 125, and I was like, this actually, even though technically, quote unquote, technically, they were the same topics, what she was doing in Math 125 was not preparing her to solve the equations in my science courses that require Math 125 as a prerequisite. So knowing that, yeah, we may have to actually go over a review and cover some concepts that I would consider part of the topical, like if you look at the syllabus of Math 125, it's in the topic outline, but it's not, it doesn't cover it. It doesn't actually review the things that you need to be talking about. So, and I've even brought that up to the math department, that your Math 125 isn't preparing my students, to do the kind of math that we need to do they need to do for their science classes. So don't be embarrassed. You did something wonderful. So I will look.
The curriculum for Math 125 is a legit joke. It really is. Like, half of the stuff is not even relevant.
I know. I was actually deeply frustrated because she was like, can you help me with my math homework? And I would look at it and I would be like, I can help you with the math. I don't know what your calculator brand, which was a big part of it in her class. Her class was like a calculator brand thing. So I think I see a student text.
I took 150 and then they made me take 125 because they changed the course description from Math 150 to Math 125. So I literally took the class twice and it was just bogus.
And it was just bogus. Yeah, okay. Yeah, put that all actually in an email. I won't use your name, but your attestation is a good example of a discussion that science needs to have with math. And if science needs to make their own math curriculum or own add-on course for like a 1 credit hour course to help you with the math in our science classes, then we need to do that, because people aren't coming into classes with the math they need, even if they take the class that says, this is the topics that we cover, and the science department looks at those topics and is like, oh yeah, that's exactly what we need for our classes. Because like I said, that my roommate had exactly the same problem, and I saw her 125, and it gave me real insight into that. So put in an email, because we can't spend the whole class on it. And I will grade your quizzes and take a look at those math problems that you had trouble with. And if I need to build a module into one of the labs where we go over the math that you need, like slowly and in detail, we will do that. But until I have a picture of where everyone is, I can't do that. Because I would love to be psychic, but I'm not. So thank you, Rodney, and definitely put it in an email. So yeah, that's rough. And yeah, it's sucky, but it's something that we need to have a conversation with. We can fix it for this class, and then I need to have what you got, your personal, and anyone who wants to send that email would be valuable, because I want to have that. You should be able to solve those equations if you've taken Math 125, and if you can't, that's a broader conversation we need to have with the math department, and something that I need to fix for this class, because you should be able to handle those. And that's not a criticism of you, that's a larger pedagogical issue. So thermal radiation, we gotta keep moving. We've gotta keep moving. And I have a very cool idea for you right here. Cool fact. You, right now, are glowing. Across the spectrum. So I have a dear friend who's like a bit of a hippie, and she's like, you create vibrations, you create waves. And for a long time I was like, hippie friend, no, we don't. Rocks don't vibrate. But in a very real, broader sense, yes, you do. In actuality, you are quietly glowing across the spectrum, okay? And this is from the fact that you are above absolute zero. So this is just a cool fact that's connected to thermal radiation. This is where we're heading. In fact, all objects above absolute zero, and in fact, objects, it doesn't even have to be a solid, all matter above absolute zero. So that includes solids, liquids, gases. And then what's the fourth one? What's the fourth state of matter? Does anyone know? Comes up in this class, because chemistry is only concerned with these three guys, but we've got a fourth state of matter to contend with. Begins with a P. Anybody willing to guess?
Plasma.
Huh?
I don't know.
No, guess.
Plasma.
Plasma. You got it, Rodney. You got it. And plasma. So solid, liquids, gases, plasmas. Okay. Release light from the full, across the full spectrum. Due to their temperature. And this is what we mean by thermal radiation, which is the light released due to an object having a temperature.
We ran off the screen.
We ran off the screen above absolute zero. So that is a definition. Where's my favorite red pen?
Just a quick question. This is gonna be on YouTube, right? Just because I missed the first portion.
Yes, this will be on YouTube. This will definitely be on YouTube. So yeah, I will this week, and also every time I post previous this day's recordings, I will also try to upload a couple of from the previous week going backwards in order. So basically you're going to see it expand in both, like as we move forward, we'll get lectures, and as we move back, because right now there's so many lectures I have to upload, it's a little overwhelming, and my machine, I discovered, is absolute crap, which is why it's been taking such a long time. So this is a really important central concept. So I will put it in a little orange box. So that you know that it is a central concept, keeping our iconography stable. So this gets into a couple of ideas are touching on this. One of these is absolute zero. And absolute zero is the coldest anything can be. Temperature has a true natural zero. Oh my gosh. Who is texting me? I don't know how to use a scientific calculator at all. Plasma infrared question mark. Okay, so whoever is texting me repeatedly, use the chat box. And if you're not comfortable saying it in front of the entire class, please use, please, you can change, I can't really share the screen on this, but it says you can do everyone, or you can do it directly to me. So if you don't want to, if anyone doesn't want to answer and suggest an answer privately, that's one of the advantages of doing this online. You don't have to put your neck out there. You can actually just shoot it privately to me. Don't be afraid to, but you need to stop texting me. You need to stop texting me during class, because this is getting a little distracting. So, but in the chat, I can see, and I can see everybody else's answers too. So, and I'm not saying don't text me ever, but texting is more to answer like a single question. Like, I don't know where the homework is. It's 8 o'clock at night. I'm going to shoot Dr. E a text. That's okay. And using it to answer questions that I'm asking you in the classroom, too many questions, too much communication. I can't text back and forth like that. So, Kelvin temperature scale. So this gets into the Kelvin temperature scale. So that is a temperature scale where each degree is equal in size, equal to a degree in Celsius, CS, and 0 is absolute 0. So has anyone seen the Kelvin temperature scale before? Like, has heard of it? Let me turn this a little bit like that. There we go. Has anyone done a Kelvin temperature scale before, or heard of it or used it in anything? Yes, excellent, excellent, Rodney, excellent, Tracy. Yes, Kelvin is, so in science, we can scale things so that they are like they're more natural. Okay, there's not so many conversions necessary in order to make it come out reasonably. So Kelvin temperature scale is great because it has a real zero that actually represents like the coldest temperature anything can be. So conversion between Kelvin and Celsius is unbelievably easy. Okay. So to go from conversion, Celsius, how do I spell Celsius? Celsius to Kelvin, okay, is pretty easy. So you just take Celsius temperature and you subtract 273.15 degrees, and that will get you your Kelvin temperature. So a good example is suppose it is 0 degrees Celsius, in other words, 32 degrees Fahrenheit outside. What temperature is it in Kelvin? Excellent. So negative 272 minus 237 point, negative 273.15. Excellent. That's perfect. Well, not. Oh, I'm sorry. Should be add. I'm like, there's no negative numbers in Kelvin scale. Just 273.15. Yes, my bad. So this is my bad. Okay. So it's 0 degrees C plus 273.15 degrees equals 273.15 degrees Kelvin. And Kelvin is indicated with a K. So, so a thinking question, what temperature does water boil at in Kelvin? I'll type that out in the chat. What temperature does water boil at in Kelvin? How'd you get there, Tracy and Rodney? How'd you get there? At 100 degrees C. Excellent. So water boils at 100 degrees C. What temperature? What temperature does it boil at in Kelvin? And the answer for that is 100 degrees C plus 273.15 degrees equals 373.15 degrees Kelvin. Okay, so that is a really simple conversion. This is our example. I have forgotten what color we use for equations. I remember we started using an equation color, pink. Pink is our equation color. So equations are in pink. and examples are in blue. So, and I know some people are like, Dr. Eby, you're a little obsessed. Yes, I am an evolutionary biologist at heart. And I know my ancient primate brain loves color coding and associates with it pretty well. So it helps me a lot. I hope it also helps you. So that gives us an idea of what we mean when we talk about Kelvin. Another important idea is intensity. So light and radiation intensity. So intensity is basically the amount or strength of the radiation. And it is a property of light, like wavelength, not live, like wavelength and frequency. Okay, so we usually think of this as brightness. Okay, we usually think of this as brightness. However, brightness sadly has another term, means something else in astronomy than brightness does in everyday language. Why is that? Because in everyday language, we mix up luminosity and brightness. So let's go ahead. Luminosity is a measure of intensity. Produced by an object. And brightness is the perceived intensity produced by an object.
So is that like a watt?
Is that like a watt? So you can measure it in watt. We usually measure light in lumens when we're talking about like light on the surface of Earth, because we're also concerned with area. We also talk about in magnitude when we're talking about stars. So slightly different ways of measuring luminosity. The easiest way of thinking of the difference between luminosity and brightness is luminosity and brightness example. So imagine headlights at night. Headlights of your car at night. If you stand right in front of your car, it's a lot brighter than if you stand a block away. But the amount of light luminosity remains unchanged. Okay. So this is a best way to understand it, or at least the way that when I was an undergraduate and I encountered this concept, this is the way that I best organize this information in my head. So if you imagine your headlights at night, if you're standing right in front of your car, like everyone's done this if they've gone camping. You're standing right, your car is right there, and somebody's like, it's too dark out, could you turn on your headlights? And then someone turns on your headlights and you're like, that is brighter than the sun, you know, because you're standing right in front of the headlights, and immediately in front of the headlights at night, it's really bright. But if you see the same car driving down the highway like a mile away from you, you can see them, but they're not nearly as overwhelming. Now, the luminosity in both cases hasn't changed because the amount of light being produced by your car's headlights is exactly the same, but the brightness has changed dramatically. So that's just a pretty simple example that'll become important when we start talking about black body curves. Okay, so black body curve, black body radiation. And I like to keep it straight. I like to call it the Planck curve, which is another name for it. And the book uses that too. But that's also known as the black body curve. So to understand black body radiation, people flash their brights at me all the time because I have those LED lights and then I flash them back and show them. Ah, okay. Yeah, so yeah, I really dislike it because I'm a runner, and if I run really early in the morning and it's super dark out and somebody's being friendly and they drive up on me, they don't realize how loud their horn is, and B, how bright their lights are to someone that's standing right outside. You have no idea how many times I've had friends drive past me and just almost murder me because my heart almost stopped because they honked their horns when they drove past going, hi, but it doesn't sound like a little meep meep when you're standing right outside the car. So are bright lights more luminous? Yes. So if your headlights are if your brights are on, your car's lights are more luminous. So you switch from, if you put your quote unquote brights on, your bright should be called your luminesces, because their luminosity, what you're doing is you're changing the luminosity. You're not changing the brightness. Although you're also changing your brightness, but you're predominantly changing what you're fundamentally changing is your luminosity. Isn't that nice? So now you can always call your brights your luminesces. And then people will be like, where did you learn that? And you will be like, astronomy class. I learned to call them my luminesces in astronomy class. Okay, moving on to black body radiation. Let's talk about first what a black body is. Let's get a black body definition. Black body. So a black body is an object that absorbs all radiation falling on it In other words, it reflects no light. Okay. So I will. That's awesome. So a black body isn't reflecting any of the light that's falling on it. So thinking question is the moon a true black body? Think about it. What's producing the light on the moon? Like, why do we see the moon glow in the night sky? The sun. So it doesn't produce its own light. So let's look. It doesn't produce its own light, right? So reflects no light is a black body. It reflects light. So is it a true black body? No, excellent. No, because it reflects light. So we will end on that note. This is an example. Okay, so we will leave on this example because it's almost that time. Does anyone have any questions before we separate for the until Monday? No, awesome. I hope you have a beautiful afternoon. Keep an eye out. I will note when the quiz is posted, and so I'm going to post the quiz notes, today's lecture. You can see why I can't get to quizzes on a Friday when I plan to. And a big part of that is, like, get to grading quizzes. A big part of that is, like, it takes a lot to post all this stuff. That takes time, especially because my computer's crappy. Hopefully later in the semester, I'm going to put in for a better computer, or they might just have to fix my ThinkPad. Hopefully we will get stuff together. So, and I'll go a little bit faster, and I can grade a little bit earlier and faster because I'm not spending all my time trying to upload things. But I really hope you have a beautiful afternoon, and thank you for spending time here in astronomy with me, and don't be afraid to send me questions. Pay attention to the Mars. Yes, that was so cool. Tragically, I was teaching during the landing